Yeah. Good. And let's talk a little bit about functional programming in C++. I will try to cover this very simple topic in 15 minutes or something. But not really. But yeah, let me introduce myself first. I guess many people from here know me, but basically Vitaly name. And I've been doing C++ for quite a while. Now I'm doing it at a remarkable company, and we're doing this very cool, fancy digital notebook that provides nice experience for writing. And we're also hiring. So if you're interested, you can navigate.
We are also hiring.
You missed the main point of the presentation. That was a joke. So, and we have a very interesting agenda today, but before, I have some very short story that encouraged me to give this talk. And like a few weeks ago, I had a chat with another developer. It was a backend developer, and guess what he said? He said, "You cannot do proper functional programming, and you're outdated C++." Guess what was the answer?
Challenge accepted.
No, the answer was define functional programming. And that's what we are going to do first. What the functional programming? Because that might be rather broad, right? But that's basically a paradigm or say a style of programming when you doing your software by applying or composing functions. But okay, you can tell it about any other programming paradigm. It's imperative or object-oriented, you do the same. But there are other more important traits, right? So you can use functions as an object. You can assign to values to the functions. You can have a functions that accept functions and return other functions. You can do recursion as a looping, and all of this stuff that leads to very nicely declarative style where you can compose your software somehow like in this way upside down from very tiny bricks, creating something larger. And this style forces you or pushes you to higher level of modularity of your software. And now let's see what kind of tools we have in C++ for doing such a things. First of all, we have obviously functions, and we have lambda functions. We've been having them probably 12 years already, or something like that. It's not a new stuff, but it just matters that we have it. And last year, there was absolutely awesome talk, given it many conferences. That was at the top of my list. Talk by Timurs of C++ Lambda idioms. Just watch it, it's very cool. With some lyrics and use cases, I would encourage you to see it. So, what else do we have? We have stood function. And in case you don't want to use lambdas and you want to some very generic and in many cases lightweight adapter or for storing different kind of functions, you can use stood function. So for this, as you can see above, we have two different functions. We have lambda function assigned to a value of an auto type, which is underline type, some closure and so on. And we have a free function add func. And we have a value of type stood function of int. And then we can assign to it both a lambda and a free function. This is very generic and very cool stuff. Now, with all of this tool, we can do the thing that's called function composition. Say we have a first function f, which is from string to int, which accepts string and returns int. Then we have function g that accepts int and returns bool. And we want to compose this stuff. I'm not sure whether it's visible. Okay, it's visible. There is this dot operator. You can read it like g after f. So we take an argument. We apply this from right to left to do it first f to this argument and then g to the result. And in Haskell, they use this operator. In many libraries in C++, we use pipe because we cannot overload dot operator, I'm afraid.
It's not really a dot, it's a little circle,
Yes,
a ring
it's a
operator,
little circle.
and you should pronounce it on, because it's this function on that function.
There are like many ways you can read it officially. So just you can read it G after F, if you will. So and this exact stuff we can interface in C++. It's, I believe, mostly valid code. So we have lambda called F, never compiled it, just wrote. So and then we have function G, so that accepts int and returns bool. Then we have a function compose. In some libraries like, say, ranges, there are already built-in functions. You can make things pipeable. You can then compose them through pipe, but in the vanilla C++ we do not have it. So we can write this teeny tiny helper, and what it does, it accepts the function and returns another function. So it's kind of a lazy stuff, right? When we invoke compose, neither G nor F invoked. We just return another function, and after that we can simply invoke H on string view, and the function would return some bool. So that's how it works. And there is a helper called colon invoke. You can just use a regular call operator. So there are probably no time for question during the lightning talk, but yeah, you can ask afterwards. Now, what else do we have? It's fairly new stuff, to be honest. It's monadic operations. I will not talk about it alone, but at the previous meetup, I had, I guess, 45 minutes talk about monadic operations in C++, and you can find it and watch. But very briefly, we have stood optional type. Piotr mentioned about it, I guess. So that the abstraction, when you need to clearly indicate absence or presence of a certain value, and it has three such an operation, so that you can chain that and then transform and or else. And here is an example. Say we have some function that used to create a user, and it returns some JSON. I'm not sure what the type is it, but if user is created, that's some. It's some JSON, some valid value. But if it's like, failed to create it, it returns just null opt, nothing. And above, there is an example when we create a user. Then we have a kind of chain stuff, or chain is usually flow, it's not lazy, it's executing as this. Then we have a transform function that would be invoked only if there is something inside of optional. It will not be invoked if the optional is empty, it will just bypass stuff. And then extract ID, say it's some other function that we extracting user ID from it. Then or else it's the thing will be called when the optional is empty, and the value just extract value from optional. But it's for this example, to assign it to something, we can, strictly speaking, chain it as long as we want. And this also affects the entire style you might want to code, because if you have this monadic type and the sorry, not monadic type, but type is monadic operations, and the next one and some other stuff, you can probably write the entire programs looking this way when you just naturally chain the things. We also have expected, which is either value or error, and this abstraction can be used when we need to not just identify absence or presence of value, but if there is some error happened, we want to have this error. And there are three monadic types, and when I was preparing this short talk, I checked CPP reference, and apparently the fourth one appeared here. It wasn't the last time I given the talk, 2 months ago. It's transform error, and basically if you have an error type, you can also transform it. There is stated, I don't need to read, but it's something you added. And those monadic operations are not implemented in any compiler so far. There is experimental implementation of the proposal TL : expected by Cybrand. Very cool, very stable. You can use it through this package. It will be working. And there is an example. you can see that there is almost no difference. We just return expected, but now we have some user and some error. User is kind of, say, not probably JSON object, but some record or structure that contains a user, and error is some error type we want to use. Then we create a user. We can again transform it, and if it's an error, the second function, like transform, will not be called, but transform error can handle error nowadays. So, or else, if it's again an error here, but there is some difference in function signatures, and with value you can extract value. So that's a very good machinery. I would encourage you to learn more about it or to experiment. Probably it might have to slightly alter or change the way you think about programming and about continuation of execution of your program. Now, it's not everything we have in C++. Not only the high order functions, not only these monadic-like operations. We also have a lot of very useful utilities provided by standard library to do functional programming. We have student invoke that I already demonstrated to you, for example, invoking stuff. We have many additional machinery to pass things by mutable or immutable references to the function, like this reference proper. We have type traits. We have concepts where you can program in compile time based on certain characteristics of your types. So you can check like whether this function returns something, some type, or whether it can be invocable with some type, and based on this you can generate your code. And another thing that can help you specifically for functional programming compile time, we have foldings. And it probably was introduced in C++ 17, but it's a proper fold expression to avoid generation extra code. So if, again, you have some time, I encourage you to navigate to the CPP reference and read about it. Very cool and very impressive stuff. What else do we have? We have actually a bunch of libraries already. It's very popular libraries that utilize many of those approaches to write code in functional style. We have libraries for processing ranges and things, and I would slightly probably correct the previous speaker that acute containers are not really ranges because many ranges stuff, they are lazy, they are not evaluated at once, many of them are non-owning, there are some things that mutated in place and so on, that kind of different concept. There are also quite a few talks of ranges. It's not here on my slide, but you can navigate and read. It's a very advanced concept. We have some libraries for reactive programming. It's for timely distributed series of values. We have relatively new stuffs from this Eric Niebler, LibVFX, and many other stuff, if I'm pronouncing it correctly. And it also uses completely functional style with composition of function, with applying it to ranges and so on. We have many libraries with strong types that you say don't want to confuse with a type and pass wrong values to your function, like you can say special types for centimeters and not just passing int or something like that. We have many implementation of various monads and like monad things. So the thing with a state that you can also compose and do pure functional programming without either memory bound or IO bound side effects, which is very impressive. And all of this stuff, they already utilize functional programming conception I talked about at the beginning. That's the question you might ask yourself now. A lot of cool abstractions. So should you give it a try or not, or you can abandon it, or it's not for your style, or you don't like it? And instead of conclusion, I have pros here, but there will be no cons. There's a spoiler. So, but anyway, this kind of style it forces you or pushes you, sorry for the word with a negative connotation, but it literally do it with you, to write more modular software with a teeny tiny functions that you compose in this chain of execution. If you also strictly following the pure functional programming without side effects, that would be, well, make your testing easier, because it's quite easier to test function without side effects, without not printing anything to output or probably not throwing an exception or something. It's very deterministic, and at some point it even helps you to utilize like some properties like referential transparency and so on. You can utilize lazy calculation when you have a very, very huge chunk of composed function, like that entire pipeline that processes some data, and then you can store it somewhere and evaluate only when you want it. And with that you can utilize, of course, a chain of computation, and all of this programming style emphasizes value semantic. And modern C++ also like slightly pushes you towards value semantic, because there are so many things like value semantic is basically where you mostly considering about the value of object rather than of the way this value is like passed, for example, by reference and so on, and pass everything by value, return everything by value. It's not entirely good definition, but good enough to understand what value semantic is. And in C++ we have like this copy elision, we have even move, we have RVO, we have NRVO, and many, many other things, which is kind of good. And the only one cons of it, that the syntax might be quite terrifying, especially for newcomers. If you ever seen the lambdas in C++ and in other languages, there is a difference, noticeable difference, especially it's like languages that meant to be pure functions, like Haskell or Scala with some questions, so on, even Rust. I should mention Rust. Yeah, and with all of this, my lightning talk is over. Thank you guys.